Okay, so what I mean when I say the algebra of graphs, it is usually when they give me something odd, like they ask me questions like, when is f of x smaller than g of x? Or they can ask me, when is f of x minus g of x equal to a constant value c, well, like 2 or negative 2. Or they ask me, when is f of x equal to g of x? Okay, or they ask me, when is f of x times g of x greater than 0 or less than 0? And they usually ask this based on the graph. So I have a graph and they ask me these type of questions. Now, which one can you immediately tell me what it means? Which one of these do most of you actually know what they mean when they ask that? Sorry? I can't.
What do you mean?
So in other words, these, they give you graphs and they ask you, when is this true, or when is that true, or when is that true, or when is that true? Which one of these will you be able to answer if they give it to you?
fx equals to x.
This one. So what do they mean by this? Sorry? They're equal, but what do they, how will you see it on the graph? Just louder, please.
Maybe like fx equals to x, it's a reflection of g.
No, on a graph, when so these aren't two graphs, so they're asking you when, for which values? For which value or values of x is, and then they give you these things.
It's an intersection.
This means they are intersecting. It is the point, it's the points where they intersect. Okay, so if I have a graph and the fx values, is this x values or y values? And g of x, is this x values or y values? Y values. F of x is the y value associated with x. G of x is the y value associated with x. And now I want the x value, so the two x values are equal, but the two y values are also equal. So if I draw a graph and there's 2 points where they intersect, the point of those points is that they have the same x values and they give the same y value. So the y value for f, there's the y value for f, is also, this is g, is also the y, so this is x. When I put x in f, I get that answer. If I put f in g, I get the same answer. In other words, f of x is equal to g of x. Does that make sense? Can you understand why they are, this is the point of intersection? Okay, what does this mean? We just did that, Ms. Sunday. What does this mean?
Point of intersection. What's the point of intersection?
This is not a point of intersection. This was when they equal, it's a point of intersection. What is this saying? The y values of f is smaller than the y values of g. So remember, these are the y values. Okay? For these x values here, if I consider these x values, okay, which ones y values are smaller, which ones y values are bigger? Is f smaller or bigger than g? Smaller, because the graph for f lies below the graph for g. So all of the values from let's call this x value a. So from negative infinity up to a, it will be true that f is smaller than g. Do you understand? All these values less than a. Now if I'm between A, let's say this is the x value B. Between A and B, we see that G, here's G, lies underneath F. So for this part, for this part here, I have that F is bigger than G. Make sense? And then for this part here, we see again, okay, here G is bigger than F again. Do you see that? G of X is bigger than F of X. So what do they ask when they ask one graph bigger or smaller than another graph? They literally ask for which X values is the one above the other one. So if I draw something like this, let's say there's a parabola and exponential function. This is fx, and let's say that's the point x is equal to 2, and that's the point, this is gx, this is the point x is equal to 5. Then fx equal to gx, then what's the answer? If they ask find the values for x for which fx is equal to gx, x, it's the points of intersection. X is equal to 2 or x is equal to 5. Okay, if they ask gx is less than fx, what are they asking? Where is g smaller or underneath f? Where is g underneath f? On the left or the right of 2? On the left, because here's g. On the left side we see f is on top. So when x is smaller than 2, if that's an equal sign, we'll also include equal. Okay, and then at each intersection, guys, it will change. So here, because at the point of intersection is there where the one goes on top of the other one, isn't it? So if g was at the bottom here, g would be at the top here. And then there's another intersection, so g would be at the bottom again. So when is g underneath f? When it's less than 2 and greater than 5. Make sense? Okay, do you see? I don't care what the y values is, but the x values are important. It's about the x values. Okay, so that is this one and that one we've done now. What would this one be? Cassandra, we just spoke about this one. What do I work out when I take the difference, when I subtract two values? The distance, yeah, the distance between two graphs. So they might ask you, when is the distance equal to 2? And that literally means, there was an exam question like that. When is the distance equal to 2? Then you'll literally find here the distance is 0 because they're on top of each other. Here, between here and here, maybe now I need to know the y values, because now let's say this is now the value 4 and that's the value 2. Okay, and let's say here we have the value 3 and here we have the value 1. We can see that at this point, and let me just change the color, at this point we have a distance of 2, but that's f is bigger and g is smaller, so fx minus gx will equal 2. Here gx is bigger minus fx is equal to 2. So it depends on what they ask, and it will now depend on what these values are. Let's say that's the value x is equal to 1 and this is the value x is equal to 4. they're asking for where is f minus g equal to 2. Then I'm finding the distance. And which one must be on top, f or g? If my answer is 2. Which one must be on top? Is f bigger or smaller than g? If my answer is 2, f is bigger. Because I get a positive answer, that means I'm having a bigger minus a smaller number. So I want to see where is f on top and g at the bottom, and the difference is 2. So this answer will be when x is 1. Okay. Then we'll get to this last one. This one is very interesting. It gets often asked when we do trig graphs, and also quite often in the inverse graphs. What it's saying is that f times g gives me a what? How would you describe this? What does greater than 0 mean? It means it's positive. What does it tell me about these two graphs? When I multiply them, I get a positive. What does it tell me about these two values?
It can be, you can say both values are positive or they are both negative.
Well done. If I have that I multiply and I get positive, it means either both are positive or both are negative at the same time. So let me give you an example. So let's draw a function and its inverse. So here's a function, and here's this function, and here is its inverse. Okay, and so this is f and this is the inverse. Now they ask me, when is the function of f times its inverse greater than 0? What it's asking me is, where is this one positive and that one positive at the same time? Or this one is negative and that one is negative at the same time. Now, again, f of x is what values? X values or y values? Y values. So if I say f of x is positive, I mean it's above the x-axis. It is positive y values. Now you notice f is always positive. So now the question is just, okay, if f is always positive, when will this one be positive? And this one will be positive from here upwards. Well, actually excluding this one, because there it's 0. So where will this, and this would probably be the point 1, okay, because that's usually the point 1. Okay, so in other words, when will this be true? When x is greater than 1, because then both of them are above the x-axis. At this point, from here on, both of them are above the x-axis. If they are something like, when is f of x times the inverse of x less than 0, it means one of them must be positive and the other one is negative. Now, where is that true? Well, this is only true, this one is always positive. So now we'll look at this one. Where is this one negative? This one is negative here. So between 0 and 1. So when is this true? When x is less than 1 or bigger than 0. Why do we exclude this? Because the inverse never gets there. It's not defined. X cannot be, x must be greater than 0 for this function. That's why we don't even consider that, because this is not defined when x is smaller than 0. It doesn't exist, so I can't multiply. Does that make sense? So I can only look, this graph never goes to negative x values. So I can only look from 0 to 1 and from 1 onwards. Okay. This is often asked in trig graphs. So if this is f and that is g, and we had to look for f times g as smaller than 1, it means where is f below and g above, or other way around. And so here you can see for this little bit, g is below and f is above. But now both of them are on the same side until we get to the next intersection. Here, between here and the next intersection, this one is above, that one is below. You see, so if we had to answer this question, we would use this part and that part up to there, and now they're both on the same side. So both are negative. So when I multiply the two graphs now, I'll get positive until I get to my next intersection. Now both of them are on either side. So again, I'll use that part of the graph, and let's say if they just restrict it there, then I'll use this little bit, I'll describe this little bit, or that little bit, or that little bit. Make sense? Okay, and that's what we call the algebra of graphs. How do I compare graphs algebraically with each other? Is that fine?